Let's see for these examples how to find out the rank of the matrices. Even though I am going to show you the crude way of finding it now, later I'll tell you some method that is called transformations, where we can apply some transformations to the matrices, and after that finding out the rank will be easy. But for now, let's go with the basic definition and the crude method. Okay. So what is the definition of a rank? We are going to find out the maximum possible square submatrix inside the matrix whose determinant is not equal to 0, and the order of that matrix square submatrix is nothing but the rank. Okay. Now see this, it is a 3 by 3 matrix. So whenever you have a 3 by 3 submatrix, if that is the biggest matrix, you have to come from there, right? So let's see if the rank of this matrix can be 3. Rank of this matrix can be 3 only when this 3 by 3 submatrix is going to have a determinant which is not equal to 0. That is nothing but if this particular matrix is non-singular, which means if the determinant is not equal to 0, then we can say that order of this matrix is 3. Now check this. The determinant of this is identity matrix, isn't it? Identity matrix I3. And we know that since it is a diagonal matrix, the determinant is nothing but the product of all elements across the principal diagonal. Now product of all elements across the principal diagonal is 1 1 1. 1 into 1 into 1 is 1. Therefore, since this determinant, let's call it A, determinant of A is not equal to 0, it is a non-singular matrix, and therefore its rank is 3. Rank of this matrix is 3. Okay. And now let's talk about this one. It is a null matrix. Now see this, it is a 3 by 3 matrix. Let's see if the order can be 3. So which means if the order of this matrix has to be 3, then the determinant should not be equal to 0. But if you find out the determinant of this, since all the elements of a row are 0, definitely the determinant of this matrix is 0. So the rank cannot be 3. 3 is ruled out. Now let's see if the rank can be 2. How can we find out? Check if any submatrix of size 2 by 2 is having a determinant which is not equal to 0. But any 2 by 2 submatrix you pick, it is always going to have a determinant 0 because all the elements are 0, right? Therefore, the rank cannot be 2. Now let's see if the rank can be 3. How can we check it? We have to take 1 by 1. Right? If the rank has to be 1, we have to take all the 1 by 1 submatrices and see if its determinant is not equal to 0, right? But then every 1 by 1 submatrix is nothing but the element itself, right? And that element is always 0. Therefore, the rank cannot be 1 as well. At least if there is one element whose value is not 0, then definitely its rank will be greater than or equal to 1. But in this case, since all the elements are zeros, the rank can never be greater than 0, right? So the rank is going to be 0. Remember this, only null matrix is the matrix for which the rank is always going to be 0. No other matrix will have a rank equal to 0. If a matrix is non-null, always its rank is going to be greater than or equal to 1, always. Okay. Now see this one. Let's see if this, it is a 3 by 3 matrix. So if it is a 3 by 3 matrix, the maximum rank can be 3. Let's see if its rank could be 3 or not. Okay. So for that reason, I am trying to find out the determinant. So you can simplify it and you can find out, or you can directly find it out here. See, this first column, this element is already 0. Therefore, I am expanding the determinant across the first column. If I do that, the determinant across the first column is going to be 1 into 6 minus 8 minus 2 into 4 minus 6. You can do this, okay? You can do the math and you can find it out that it is not equal to 0. So what does it mean? It is a non-singular matrix, which means it is a 3 by 3 matrix whose determinant is not equal to 0. Therefore, the rank of this matrix could be 3, because the matrix is going to contain in itself the same matrix of size 3 by 3 whose determinant is not equal to 0. That is the maximum submatrix. Therefore, rank is going to be 3. So rank of this particular matrix is 3. Okay. Now let's see the next one. Let's see what could be the rank of this one. Now you just try to expand it. You can even simplify it and expand it. or you can directly expand it. I'm just expanding it across the first row. So if we expand it across the first row, it is going to be 1 into 24 minus 25 minus, I think you know how to write this, the cofactors, 2 into 18 minus 20 plus 3 into 15 minus 16, right? That equal to minus 1, and here minus 2 into minus 2, here plus 3 into minus 1, which is nothing but minus 1 plus 4 minus 3, so which is equal to 0. Since the determinant of this matrix is 0, the determinant of this one is 0, right? Therefore it is singular matrix, and so its rank cannot be 3. It cannot be 3. Now let's see if the rank can be 2. How can we find out? We have to find out 2 by 2 submatrices inside this whose rank can be equal to, whose determinant is not equal to 0, right? So let's see this one. This is a 2 by 2 matrix, right? So what is the size of it? 2 by 2. 1, 2, 3, 4. And if you find out the determinant of it, it is going to be 4 minus 6, which is minus 2, which is not equal to 0. Therefore we are able to find a 2 by 2 submatrix inside the matrix whose determinant is not equal to 0. Therefore we can say that rank of this matrix is equal to 2. Okay. Now similarly you can solve this one also. Next one also, I think you get rank of this one as 1, I think. Okay, so next one you just try to find it out. You will get the rank of this one as 1, because the determinant, when you find it out, it is going to be 0. We can check this. Okay, I'll do that. Why to leave it to you? Okay, see this one. Now if you observe this, the first row and the last row are identical. Whenever two rows or two columns are identical or scalar multiplication of the other one, we know that determinant is going to be 0. Therefore determinant of this one is 0. See, if you don't understand this way, you can apply the transformations. If you replace row 3 by row 3 minus row 1, then you are going to get the entire row as zeros, right? And once you get the entire row as zeros, then you can expand the determinant across that row and you are going to get zeros, right? Therefore, since the determinant of this 3 by 3 matrix is 0, we can say that the rank cannot be 3. Now let's see if the rank can be 2. How can we find out? Just take every 2 by 2 submatrix and see if any one of them is going to have a non-zero determinant. If we can find it, we can say that it is rank is 2. Now we can check this. We can take any 2 by 2 submatrix. Everything will even out and cancel out, and then the determinant becomes 0. Either you take this one, or you take this, or you take this, okay, or you take this. Anyway, any possibilities you take, right, or you take these 4, any possibilities you take, you are always going to end up with a 0 determinant. Therefore the rank of this is also not equal to 2, because we cannot find out any 2 by 2 submatrices whose determinant is not equal to 0. Therefore we have to find out 1 by 1 submatrix whose determinant cannot be equal to 0. But if you watch it, every 1 by 2 submatrix, 1 by 1 submatrix is nothing but the number itself. And so there are many numbers which are not equal to 0, which can be considered as a 1 by 1 submatrix, right, and whose determinant is not equal to 0. Therefore we can say that rank of this one is 1. Okay, and now observe this one. So order of this one is 2 by 4, right, 2 rows and then 4 columns. So what can be the rank of this? Rank of this matrix cannot be more than 2. That is what we are trying to discuss in one of the points. See this, if the size of the matrix itself is 2 by 4, the rank of this matrix cannot be greater than 2, because there is no way there can be a 3 by 3 square submatrix inside this 2 by 4. If there has to be a 3 by 3 square submatrix, then the number of rows have to be 3, but then the number of rows are restricted to be 2. Therefore we cannot have 3 by 3 square submatrix, or we cannot have 4 by 4 submatrix. Therefore the maximum square submatrix which can be present in this matrix is just a 2 by 2 matrix. Okay, so remember this, whenever we have the size of a matrix as m by n, okay, then the maximum order possible, or the maximum rank, the rank is always less than or equal to, which means the maximum rank possible will be minimum of m comma n. What does it mean? If you have a square, submatrix of, if you have a matrix of size 2 by 4, then the maximum rank can never be greater than 2. It can be 2 in best case. How? If you are able to find out a 2 by 2 submatrix in this matrix whose determinant is not equal to 0, then we can say that the rank is 2. Just check this. You can try to find out the 2 by 2 matrix. See this, 2 4 3 5, 2 4 3 5. Now check this one, 5 into 2, it is nothing but 10 minus 12, which is not equal to 0. Therefore, we are able to find out a square submatrix. The submatrix should always be square, otherwise we cannot find out the determinant. You already know that, right? We cannot find the determinants of a non-square matrix. We can find determinants only of square matrices, right? Now check this. We are able to find out a 2 by 2 square submatrix whose determinant is not equal to 0. Therefore, we can say that the rank of this matrix is 2, right? Because of this, even if you are able to find out at least one square such submatrix, it is enough. You need not check for all the 2 by 2 submatrices. One is enough. We are able to find it. Okay, so the rank of this one is 2. Okay, so this is a crude way of doing it. We cannot do it if the matrix is going to be very big. So what I'll tell you is we shall talk about, okay, in the next video we shall see the other methods. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.